math is part of the lesson. Name of the transversal XY. Okay. This is my transversal right here. It cuts 2 or more lines. Okay. What types of angles would be G and L? So GL would be called vertically opposite. That's it. What types of angles are H and I? So HI would be consecutive interior. Consecutive interior angles. Okay. What types would be K and M? KM along the transversal on the same side. One is outside, one is inside. That's corresponding angles. G and N. So GN alternate exterior. Okay. Alternate exterior angles. HM. HM would be alternate interior. Everything is worth a mark today. If M is 100, then L is what? So M is here, L is there. Anybody know what CIAs tend to add up to 180? So it should have been 80 degrees. If N is 57, so if this is 57, then J is, right, it would be, these are supplementary. So that would give a 123. Angles whose total equals to 180 would be called supplementary. It's right to complement someone. Right is the 90. So complementary add up to 90. Supplementary add up to 180. And a blast from the past. What's the range of this? There's no word problem associated with it. But we know that the vertex is +3, 2, right? That's the coordinate of the vertex. This is pointing up, right? A is positive, so this points up. So the lowest point is 3, 2, right? That's the vertex. So my range would be y is greater than or equal to 2. Or you could go 2 to infinity. You thought you could escape range. It'll find you wherever you are. State the y-intercept of the previous question. You could use your calculator, or you can just go y is equal to 2 times -3 squared, because x is equal to 0 at that point, right? Plus 2. That would be, this is 9 positive times 2 is 18 plus 2, which is in turn 20. So 0, 20 is the y-intercept. You could have used the calculator for that as well. 1 mark. How many x-intercepts? A is negative, K is positive, so 2 x-intercepts. You could have also used your calculator for that, but why? Okay. So this is all gone. 13 of 15 is gone. So 12 marks for this. You have your first and last name there, and hand it in, please. Pass it forward. Some of you are going to work, probably. That's what I did. Day off, go work. Make money. There's nothing wrong with relaxing. Page 6. We looked at 2 conjectures, 2 theories, basically, right? We were told that if lines are parallel, if we are told this is true, then all of these follow, right? That's just a fact. We can rely on this to be true. On the other side, if they're asking us, hey, are lines parallel? You know if they're parallel? How can you tell? You need to show if one of the 4 is true. Because it turns out that if you show that one of these is true, they all are true, right? So that's why we're not going to bother looking for every single one of them. We're just going to pick, hey, which one of these? And you know which one you're going to pick? The one that stands out more to you, okay? The one that stands out, and I'm going to show you how to do that. We then looked at this graph made by the sketch made by Desmos. It's to scale, and we actually confirmed, right, that we saw, hey, the orange angles, those are called corresponding, and they were equal. And then we looked into the CIAs, right, the consecutive interior angles, and they ended up adding up to 180. So that was also true, right? We looked at alternate interior angles, the green ones. They were also equal, right? So everything kind of just came together. Same with the alternate exterior out here, and that is true. We could then focus on this transversal if we had wanted to, and come up with the same conclusion. Okay? And I know you're excited and you're like, oh my goodness, like just keep talking about this all day, right? I know you're thinking that, but can I just say one more thing? These two lines, are they parallel? And you're like, obviously not. They don't look parallel at all to me. Well, how could you know for sure? Like, do this with me. Flip this, because sometimes it's better. If you flip this like that, and you're like, hey, is this line parallel to this line? And let's try. These are what? These are called what? These two angles here. They're consecutive interior, right? Do they add up to 180? 218 out the window. What would this angle and this one be called normally? Alternate exterior. Are they the same? No. So it all goes down the drain, right? So we would definitely say not just by observation, but actually mathematically we could prove that these are not parallel, these two lines. Because if we focus along this transversal, everything, all the action happens along the transversal, right? And then you jump between the lines to see what's happening. So let's put this to practice, okay? So now we're going to actually use what we learned to solve or to prove whether or not lines are parallel. Okay, so page 7 here. I'm not going to do all of them. I'm going to do a few, and then the rest I'm going to assume you will try for homework. Okay, so I'm going to kind of skip through various pages here. First off, proving if lines are parallel. We don't know if they are parallel. Okay, number 1, try to find an angle pair with a name. Right? Maybe I should highlight that. Find an angle pair with a name. One of the four names you know. That would be my first step. Like, can you find a pair of angles that you have a name for that's based on their location? You might have to resort to sum of triangle is equal to 180. You might have to resort to, supplementary angles, vertically opposite angles, straight angles. Sum of quads is 360, etc. You might have to use and rely on these to get you an angle to even have a pair that you know the name for. Okay, so I'll show you how to do that. Check to see if the property about them is true. Right? See if property about them is true. That would be your second step. If yes, lines are parallel. If no, lines are not parallel. So we would say AB is parallel to CD, let's say, or you would say AB is not parallel to CD. Okay, so those are your page 7. Those are your options. Okay. AB parallel to CD or AB is not parallel to CD. So let's try this out. In each diagram, prove or show whether or not EF is parallel to GH. So in every scenario, we're asking, hey, is EF parallel to GH? Same with here, EF, GH, okay? So we're gonna do that. Is there more than one way to justify? And the answer is yes. Usually there's more than one way to justify, but you just need to pick one. Okay, so in this case, this is my transversal. Okay, this is the transversal that I'm going to travel along. And do you see an angle pair with that you have a name for? Look carefully. 113? Oh, because they're equal. I have a name for them because they're equal. No, you don't have a name because they're equal. You have a name based on the location. These are called what? Alternate exterior angles. That's what they're called. Okay. I found the alternate exterior angles. And the reason I'm writing this out is because some students struggle just looking at the notes, like, how did that even happen? Like, how did you go about it, right? I found the alternate exterior angles, right? That would be step number 1. These angles are congruent, right? That's an observation. So you have a name, alternate exterior. You notice that they're congruent. And your third step is EF is parallel to GH, comma, because alternate exterior angles are congruent. That is the justification as to how you came up with that. It's easy as 1, 2, 3, right? That's how it, not always. This is like easy, like the easiest case. It stands out. You don't have to do any extra work. Could you have used a different pair of angles? 67 and 67, what are they called? Corresponding, right? Corresponding. You could have said, hey, I noticed that there are corresponding angles, and I noticed that they're congruent. Therefore, EF is parallel to GH. That could have been another way to go about it. Okay. You want to go even crazier. If you want to go, these are vertically opposite, right? Technically, this is 113. Maybe don't write that down. Just let me doodle here. This is 113 because vertically opposite angles are. What do these two add up to? Add up to 180. So you could have also said, hey, I noticed that consecutive interior angles are supplementary or add up to 180. Same. Therefore, EF is parallel to GH. So technically, you have 4 ways to justify that lines are parallel. Corresponding, alternate interior, alternate exterior, and consecutive interior. Those 4 are, if you can somehow find those, then you can prove that something is parallel. Let's try one more. A little bit more work on this one. So let's say this is an AC. Diverse staff. Now it's alumni. Guess staff isn't good enough. Don't blame them. Let's try this one here. So I'm asking you, hey, prove that EF is parallel to GH. We're going to travel along the transversal. Hey, travel along the transversal. Travel along this one. Stay with me, okay? I know this is very exciting stuff, but don't fall asleep on me. Do we have a name for these two? We actually don't. We don't have a name. There's no. Oh, it's alternate something, Mr. Dirksen. This one is outside. This one is inside. If we knew this one, then we have alternate interior. See you. Have a good one. Enjoy. So what I'm going to do, this is what I'm going to do. I'm going to make an observation. I can't see an angle pair that has a name. So I'm thinking out loud here, right? I cannot see an angle pair that has a name. So do some work. Therefore, calculate or determine another angle. That highlighter really bled through, from the previous page. I hope that doesn't throw you off too much. So you can go many ways. I'm gonna go. How about we find this one here? I'm gonna use a different color, and I'm just gonna say, and I give you full permission to do that right on the diagram, and just tell me how you got that. You got that because vertically opposite angles are congruent. That's how you found that. I found a pair called consecutive interior. So this is where your artistic side comes out. You just express what you're doing, right? Just tell me what you're doing. I found a pair called consecutive interior angles. What will I do next? The second is checking the property. I'm going to check 109 plus 70 is 179. That's a problem, isn't it? But it's supposed to be 180, right? But it's so close, Mr. Erickson. Let's just make it parallel. No, we can't, right? Mathematically, we can't. So 3. EF is not parallel to GH since they are not sorry, that doesn't sound right. Since consecutive interior angles are not, I'm jumping the gun here. Consecutive interior angles are not supplementary. Can I say don't add up to 180? Sure, I'm okay with that. So you don't have to do it in this exact way, but I found that students struggle when I just leave it open-ended. It's like, hey, just figure it out yourselves, go, right? So I kind of give you a bit of a model to go by. And it hopefully allows you to I found a pair called consecutive interior. Let's highlight those. This one and this one, right? I focused on those. You could have found, just look up here real quick. If this is 70, we know this is 110. This one right here. So 110 and 109, these two would have been considered corresponding, and they're not congruent. So it fails there too. So you kind of do like a test to see if it's going to stand or if it's going to fail. Yeah. Go ahead. Let's go to page 8. Here you go. So here we go. Guys, the question is still, is EF parallel to GH? Okay, EF parallel to GH. That is the question. Can you find a pair? So you have to be careful. This is transversal 1, and this would be considered transversal 2 in this case. And the quest is to figure out if these are parallel. And by the way, this 40 belongs up here. Okay, this 40 is right up here, not here, in case you're wondering. And so you're going to travel along both transversals and see if there's a pair that you know. Okay. So in this case, if you follow along this transversal, the only one you know is 75 and way up here 40, but it's not connected here. We can't relate here. We can't relate anything here. Let's go over to this other transversal. We travel along it. There's this is 65. There's that 40 up here, but it's not anywhere here. We need it to be here or here, around where the transversal intersects. So we have a problem here. Okay. Can see a pair with name. Let's shorten this now. Okay. Can see a pair with name. So I need to solve. I need to figure stuff out. Do you see a way to possibly get an angle in here somehow? Think of sum of triangle. Think of sum of a quadrilateral. Think of any of those. Can you possibly get another angle in there somehow? And if you look carefully, there's a triangle there. I'm going to use this highlighter here to just show you. What if we focused on this? And it takes practice to start to see things, right? But let's focus on that triangle, because if you think about it, you've got the 40, you've got the 75. You can easily find this angle right here. I'm going to call this Y, okay? Just inside there, angle Y. So I'm going to say that angle Y is going to be 180 minus 40 minus 75. And if you do that, you get this is 40, 65. And I use sum. Try to justify everything you find in this unit. Okay? We use the sum of 180 rule to come up with the 65 right here. And if you'd like, you can write that in now. As long as you show me some trail of work, if you had put the 65 in there and an arrow going saying sum of triangles 180, that's how I found that, I'm fine with that. So now I have a pair with a name. What's the name? A name. What are these ones called? Alternate. I haven't looked at your ACs yet, so I'm assuming you know your angles. Okay. These are called alternate interior, right? So this is my transversal, alternate interior. So there'll be alternate interior angles. I have my name. I'm going to highlight that with orange. And now I'm going to see if the property is true. I'm going to say, I can look at it, it's like, hey, they are congruent. So I can conclude EF is parallel to GH. EF is parallel to GH. Why? Because alternate interior angles are congruent. Bingo, you're done. I think I'm gonna stop there. And so this one, let me just check 1 second here. This one is going to be homework. But I will give you an added challenge. This is transversal 1 and this is transversal 2. I will say this. Show if EF is parallel to GH along both transversals. What do you mean with that, Mr. Erickson? That sounds kind of bizarre to me. This is what I'm saying, okay? Once you wrote it down, I'm going to tell you what I mean with that. I want you to do this. I want you to cover this up and pretend like it's not there. And then just focus on this. How can you show whether or not EF is parallel to GH just with along this transversal here? Then you're going to forget about that one and pretend like this is a whole nother question and do it again along this transversal. Your answer should be the same, because once you determine EF and GH are parallel or not, it doesn't matter. It doesn't matter how many times I would cut it along the way, you will get the same conclusion. So that's your homework. That's one of the questions. Come with me. Page 9, this is the other application. This is the one you will like more because it's we're not proving anything here. Page 9. And I'm going to wrap it up after a couple of these examples, okay? Calculate the unknown values. Show work and justify answers, okay? I will call this mystery angles. Can we go at the top? Mystery angles. We can highlight that. Look at this diagram. They should all be labeled, okay? If we're not proving, then we're assuming that lines are parallel. So for example, watch this, right? These markings are important because they guarantee us that the lines are parallel, where we do not have to prove it. We do not have to prove it. You're not proving anything here. So we can just assume, right? We're assuming alternate. I don't have room for that, but maybe up here. Let's do this up here. We know that alternate interior, alternate exterior, corresponding, and CIAs, right? CIAs need to add up to 180. All the other ones are congruent. That is always in the back of your head. You know that that is true because we're told lines are parallel. Okay. So if this is 116, and we're asked to find this one up here, what are these two called? Alternate exterior. Okay. So we know that they're supposed to be the same, right? So question mark, I don't like question mark as a notation, but we're just going to go with it, is 116 degrees. If you still want to watch it on that game, you can buy tickets at the door for $2. Alternate exterior angles are congruent, right? So you told me it's 116. Why? Because you know that alternate exterior angles are supposed to be congruent. As easy as that. Over here, oops. This is 100, and you're supposed to get this one. Oh, I know what those are called. I know that these are alternate interior, and they're supposed to be the same. And I'm just going to justify that alternate interior angles are congruent. Bingo. So that's how you do. These are one-offs, short and sweet, right? These would be like the shorts in on what is it, on YouTube or whatever. It's like very short, straight to the point. You just have to figure out why. You have to tell me why you came up with that number. That's the justification if you want full marks. Okay. So the rest, I'm going to leave those up to you. I'll do one more on this page. This one right here, 6. This is one that's different. What are those two called? CIAs, yes. I prefer you still to write them out. Don't just say CIA. CIA is to help you remember. So I will say that what? They're not 101, right? This isn't 101, right? This is 79. Because they're supposed to add up to 180. So it's question mark is 79 degrees because consecutive interior angles equal to 180. I'm okay with that. So that's the one where you can't just say they're the same. Consecutive interior, you will have to subtract from 180 to get that answer. Yeah, I think I'm gonna stop. So I'm gonna give you more homework for these types than to the proving ones. So let me just back up here because I need to kind of see how my keys work a little bit. So when I look at the other pages, 10. Yeah. All the way to page 12. So 9 to 12. And you might think that's outrageous. I'm going to go on strike. Right? It's not that bad. Like it doesn't take you long to answer these, right? Page 9 to 12. But 11 and 12 gets a little trickier. So before we pack, I will do one there so you can't tell me that I didn't give you an example. And I know you're saying, like, you keep on saying that, like, when is it actually going to be over? After this example, I promise. Whoa. Whoa, this is going, this is too much. I can't handle that, right? Don't worry about all the other lines, okay? You just focus on, for example, in this case, these numbers are along this transversal here. So I will focus on that transversal. And you simply look and say, hey, this one right here and this one right here are what? CIAs, right? So you proceed the same way as before. Don't let all the lines that have been added distract you. I'm just giving you guidelines. Let's go to 15 and then we're done, I promise. What are these ones called? This one here and this one over here. Are they still CIAs? What about this one here, Mr. Dixon? Forget about it. Forget about, like, if you travel along this transversal here and they're saying, hey, what about this one and this one? Forget about what's in between. You just focus on those two, right? And it's cutting through these two lines. So you're just wondering, what are those two going to be? Those are CIAs still. Okay. So all the way to page 12. And that's it for today.